Hello, my name is Jeremy. This is uh, a extra credit presentation on collection. I am currently a collections system operator, grade level 3. I hold my CWEA, grade level 3. I currently work at Irvine Ranch Water District, and my main daily duty throughout the day is doing CCTV inspection and sewer line maintenance. Um, we currently televise and clean our system. Uh, we try to televise our system every 10 years, which is what the EPA recommends. And then our sewer system uh, pretty much is our main line to our sewer treatment plant. We have a branch system. Our sewer flows from our residential and our businesses into the wastewater treatment plant. So I want to go kind of go over what NASSCO is and how it's related to wastewater and what our infrastructure is like. So NASSCO, so we'll start with it's the National Association of Sewer Service Companies. NASSCO has been around for quite some time. It started in the late 80s in the UK and eventually made its way here to the United States uh, around the early 90s. Um, NASSCO has been implementing a pipeline assessment certification program. It's a standardized uh, system for consistency in the way we evaluate sewer pipe condition and how we manage those inspection results. Um, yeah, no, NASSCO has been an association dedicated to evaluating sewers and its consistent cohesiveness. It's all the technical evaluations of sewer mains that are assessed to a high level industry standard. These standards in the U.S. have previously were not really met too often. There was a lot of inconsistencies in sewer line inspection, and a lot of operators didn't really know what to code certain defects within a pipe section. Uh, NASSCO uh, set a benchmark for sewer pipe assessment and condition assessment. Uh, you would get assessments from different inspectors, and a crack to one inspector could mean a fracture to another inspector. Um, it really wasn't standardized. NASSCO's mission statement is to set the industry standards for the assessment and maintenance and rehabilitation of underground infrastructure and to assure the continued acceptance and growth of trenchless technologies. So we're going to go ahead and move on to what we inspect out in the field and what do we maintain. So the sewer pipes usually are going to be your mainline sewer lines out in the street, hard rigid pipe or flexible pipe, could be PVC. Usually they're clay pipe, and they carry the sewage designed to carry the mainline flow from a house or a business uh, to the treatment plant. So the PACP program is the Pipeline Assessment Certification Program, is what it's PACP stands for. That's our pretty much mainline inspections we do every day. MACP, manhole inspections, are connection nodes within the sewer system or stormwater system consisting of influent effluent. Pipes generally are fed with gravity and they move sewage downstream into a treatment facility where and they can start the reclamation process. But manholes are the access nodes within that sewer system. And then we have laterals, and laterals are the smaller mainline connections built and designed by their building and the city developers to carry the waste from the home or business into the sewer mainline. Laterals are generally smaller, 4-inch, 6-inch, up could possibly be 8-inch, but they are relevant, smaller in size, relevant to the sewer main, and usually are not maintained by a city or county or water district. So what is the PACP inspection? Any inspection of a pipe segment assessed within the piping system recorded and the structure of the rubric of NASSCO's PACP. So this is PACP. You're only using PACP codes. You're only using the PACP header. You're only using certain aspects that NASSCO has designed into the system. And it'll consist of proper headers and coding and then a video and photograph survey. So PACP with the creation of PACP, it's been a very useful tool for many years. We've been able to have two operators do the same section of pipe and inspect the same section of pipe and produce the same results within that section. Coding similar, coding the same codes, and making the same observations. So we're getting consistency with a PACP inspection. The assessment, when you break down the assessment, to the right you have your pretty common PACP header. These headers include anything from the pipe, segment length, relative location details, pipe size, pipe shape, pipe material, upstream manhole data, downstream manhole data, pipe segment lateral data, consequence of failure data, defect codes, and then the condition grades. There's also areas that are not red. All the red fields are requirements of PACP, but there's also fields that are not red, that are black. These fields contain like lining methods, the year constructed, year renewed, information that you may not necessarily need right at the moment, but it's also just a good thing to fill in if you have that information, because you'll never know, who the reviewer of these assessments is going to be. It could be an engineer, could be a district manager, it could be the next guy in line to do the next inspection. So these headings and the actual assessment, you're going to go ahead and input all this information on this header, and this header information goes for every survey that is done. So most importantly, one of the main things you have to remember when you're doing a PCP inspection is you want to know who's doing the inspection. So of course number one is surveyed by up here, and you're going to make sure you put your name on that inspection, so down in the future, that's accountability. That's you inspected that pipe, and that is your inspection. The condition assessment, we kind of went over the PACP condition assessment. Gives grades and then can determine a segment score. And the segment scores can be used to calculate likelihood of failure for pipelines. And then the modified PACP quick rating system bases its highest grade of defect observed within a particular pipe segment. So the grading system, you have 5, 4, 3, 2, 1, with 5 being the most significant defect and then 1 being the most minor defect. So you could have a broken pipe or a collapsed pipe that would signify a grade 5 defect. And that would be in a quick assessment. You would say, okay, grade 5 defects are the highest. Those are the pipes we need to fix immediately. Grade 1 minor defects, you do want to look at those, but those may be able to be looked at later on down the road. So the structural maintenance and capacity, when you're doing sewer line inspections, you're definitely looking at the structural defects. These defects are able to help you estimate the pipe's performance or remaining useful life, and then you can plan on making decisions about repair or replacement of that pipe. Structural defects tend to be the red flag when you're doing an inspection, and you might find a fracture or uh, you know the surface of the pipe wall missing, or a hole in the pipe. uh, there's those are usually the big red flags you want to look out for structural defects. Those are pretty important when doing your inspections. You want to make sure you correctly note those defects uh, in the inspection. And then when you have your O&M maintenance defects, you're identifying trouble spots. You're looking to stop an overflow, and you're becoming proactive in the areas that could potentially become an emergency area. So you're looking at grease buildup, anything that's going to restrict flow, like roots, debris, sediment. Anything you want to keep the sewage in the pipe. One of the main goals of a collection system is to stop sanitary sewer overflows, and you want to be proactive in that, and keep that sewage in the line. You don't want it to spill out on the street. Those spills, come with hefty fines, and they don't look good on the uh, they're just not a good look for your collection systems technicians. Um, so yeah, when you're doing your inspection, you're going to look for those those maintenance issues. Um, Anything you know that you would think that would cause a stoppage or an overflow. So, and then lastly, last issue is we look at capacity. Doing a CCTV and evaluation, you can determine the specific location and cause of I&I, and in many cases an I&I is evaluated with a flow meter, but with CCTV you actually get a live video of the flow, and you can always reevaluate those areas during capacity needs. So during rain events, you can rush out with a camera, take a look. Okay, 25% flow capacity. All that's recorded in each survey as the flow capacity increases, and maybe say a sag in the pipe or a belly or flat spot. You can see the water level mark. You'll see uh, every inspection includes a water level code and then a water level mark. Um, and you can evaluate that change in flow as a percentage, 10%, 5% change of flow. During a rain event, you can, always uh, look at that change in flow with the live video camera with the CCTV inspection. So this is a condition assessment window, and this is actually software we use out in Irvine. You can see that the CCTV survey header, everything is manually entered. There are systems that implement GIS. Those systems can track which surveys you've done, which surveys need to be done, which surveys that are in critical areas, the consequence of failure areas, which surveys maybe you're wanting to inspect lines that were done a certain year, and you can track all that stuff with this computerized system and database system. As you can see, there are the red fields required for our PACP inspection. And then down below you have our defects. In the defect window, you have start defect with the beginning code, followed by an AMH, which is a manhole code, and then the remarks. The remarks are going to tell you your manhole number, and then the water level right below that at 0 feet, 10%. As you move down the pipe, each code is encoded at a clock position, a footage count position, and there's a timestamp in the video timestamp with a picture or without a picture. So this window pane, it's generally open all day. You're always inputting codes. Your each pipe section is going to have a new survey. The camera will run from access point to access point, and after you finish your inspection, you'll start the new survey with the same start code, just with new manhole numbers. And let's see, you can see here there's a broken pipe. It's coded as a B, and the 10 to 8 o'clock position is the clock position and lower pipe location, circumferential location for this broken pipe. So the technology for the PACP, MACP, and LACP inspections, there's a multitude of cameras out. There's the pole-mounted camera with a video. It's often used doing just manhole inspections. It's quick. It's a zoom pretty much camera. It's attached to a pole, so it does not travel inside the pipe segment. It's just for the quick look at the manhole structure and possibly 10 to 20 feet upstream and downstream of the manhole. And then you have your conventional pan and tilt camera. These usually are on a transporter. They're the conventional pan and tilt is pretty commonly used still today. It is probably 95% of the camera systems out there that are used today. They tend to be relatively cheap, less than $100,000 sort of system, and you can get pretty good video and a pretty good inspection with a conventional pan and tilt camera. The new duck camera or side scan camera or panorama camera, they are a new technology. It's actually two cameras built into one transport unit, and to describe the side scan camera, you pretty much have an ongoing picture as you travel down the line from both angles. You get the front camera and the back camera. It's hard to explain, so we'll kind of go into that a little farther a few slides later. But then you have your manual push cable camera, and these are done usually your plumbing company, your local plumber will have a push cable camera. They're mainly for smaller segments of pipe, usually residential lines. I think the smallest I've seen a push camera is probably like a 1-inch pipe. You can get a pretty good pretty good picture with a push camera, but then again you're limited by the flow level. If the flow level is too high in that 1-inch pipe, your camera size is relative to the pipe size. So you want to always to get the best picture, keep the camera above the flow level. And then I've also seen the GoPro attached to a skateboard, tied to a rope system, and some homemade, just get it done type system. And it's worked for storm drain inverts, they're culverts, and outfalls. That'll do for a quick inspection. So that's the panorama camera. That's the side scan camera that we're going to go ahead and look a little bit further into in a couple slides later. This side scan camera, you can see there is the two cameras on the front and on the back of this, giving you, if you were to fold this camera, this whole system in half, you would get a full 360-degree view of the system, of the pipe segment. And we'll go ahead and pull up the rest of the pictures. These are so that you have the pole camera up here on the top right, your standard pan and tilt camera down to the left, bottom left, the push camera, cable push camera at the bottom here, and of course your GoPro. So the application for the side scan camera and the conventional cameras, side by side, these are two videos playing at the same time. The left inspection is your conventional pan and tilt, and on the right hand side you have the new side scanned panorama camera. And each provides the same function for NASSCO coding in a pipeline inspection, but the conventional pan and tilt camera, you're actually coding live as you watch the inspection. So we'll go ahead and fast forward this left inspection, and you can see image quality is okay. Panorama is going to give you a better image quality. Panorama is going to have a 4K camera. The Panorama is just going to give you more inspections per day, and as it travels down the line, it's going to give you the 360 or the 360 degree view of the pipe segment, while as the conventional pan and tilt on the left is just going to give you that 180 degree view of just what you're looking at the front side of the camera. And as the inspection on the conventional pan and tilt is that as you progress through the pipe segment, you're stopping to code different things. You're stopping to make your notations. While as on the the side scan, your data collection is all done in the field, and then the data input is done back in the office. These types of different types of cameras, cost-wise, the pan and tilt is going to be cheaper than the side scan on the right, but you do get a lot of options with this side scan panorama camera. So the issues between the two inspection systems operators, the pan and tilt, the cons: operators are on-site compiling reports within each manhole locating, and during the live video recording, operators tend to operate slower due to the hands-on experience. There's a lot of moving parts in these pan and tilt cameras. They tend to be less cost effective. You can easily be damaged by an operator. And then your daily footage tends to be lower due to the operator's composition of on-site reports. The side scan, it's all reporting is done in post-processing away from dangerous locations and roadways and easements, and deductions and overall cost per linear foot saved in operator costs. You're saving money in traffic control, equipment maintenance, and the coding of observations. So just a general less time you're spending out in the field making those notations. Um, there's no moving parts that are designed within the camera. Simply, they're lowering the camera into the manhole is simple. You don't have to move much on the camera to start your inspection. And then the side scan boasts up to 400 feet within 15 minutes. And there really isn't a footage. There's not really a footage within a time frame for pan and tilt because it's all operator dependent, and it depends on the person and how good of an operator do you have in that unit operating that pan and tilt camera and doing that PCP inspection. So of course we have um, our choice here would be the winner would be the pipeline inspection. The pipeline inspection to NASSCO coding would be the side scan option. It's cost effective. The side scanning offers a rapid assessment of the pipelines while providing data needed to prioritize rehab and maintenance. Side scanning takes the length of the pipe and it pretty much lays it in that flat image. And side scanning can makes analysis faster. It's just you don't have to watch tons and tons of hours of footage, and that'll get to an operator out in the field watching that footage every day and doing it over and over again. It does make a good operator, but it's a lot of video to inspect. There's a lot of pipeline to inspect. I think out in Irvine, uh, there's I want to say over 180 miles of sewer pipe out in Irvine to inspect every 10 years. So we're going to go ahead and go to our last slide, and this is our sources page. We want to thank you for listening to our presentation about PACP inspection and side scan cameras.